All right, today I will tell you a fairy tale about the three little pigs. And in order to tell this fairy tale, I will use domain-driven design and clean architecture. So, two remarks at the beginning of the presentation. First of all, it's not the presentation for people who don't know anything about domain-driven design. It's rather for people who are tired of cargo or product examples and are looking for some other example. Here is the three little pigs, so the domain quite easy to follow. And the second remark is that the full title, when I have more characters to put, contains my understanding of domain-driven design and clean architecture. And this leads us to the conclusion, worth reminding, that context is important. And here, fortunately, Google is smart enough to guess that the one who wrote "remove child from parent with fork" is not a child murderer. Google is smart enough to guess the context of the user based on the data, based on the historical search results, and it's hard, therefore, to guess the context without such data. So a couple of words about myself. My name is Mateusz. My surname is hard even for Polish people. That's why you can find me with Mat3e, shorter login here and there. Regarding GitHub, it's worth remembering this link. These are the slides of this presentation, already online. You can check it even now. It should work. Another important GitHub link is the repository of the code, which will be presented in the second half of the presentation. So this is Mat3e 3pigs-DDD. At daily basis, I work at Glovo, and I have some Udemy courses, I have some part-time activities, so it's kinda interesting because Glovo is also a user-facing application with a lot of business rules. We try to stand out from the competition, so we are also using domain-driven design at daily basis. Reminder about Slido, there is a URL called slido.do, and GeeCON 2022 is the password you should use to ask me questions. So feel free to ask, preferably about the code I will show, but also about DDD in general, no problem with that. So let's focus on DDD first, as it's the first part of the title. So DDD can be divided into strategic and tactical one, and the strategic is the first one we will start with. So for domain-driven design, we are trying to find domains, so the problems we want to solve. The core domain is the place where we are getting most money from the customers in our system, right? So the core domain is surrounded by supporting subdomains, and there are also generic subdomains. I'm not going to dive much into DDD, as I said, so that's just a simple reminder. So that was the problem space. Now solution. For problems, we need solutions, so bounded context is a way to go. And putting it into the example of the three little pigs, it's easy to spot the difference, for instance, between the red hood and the three little piggies. So we can treat both words as different bounded contexts, yeah? And in bounded context, it's crucial to spot the ubiquitous language, to spot the behaviors combined with the most crucial words. And in both words, both red hood and three pigs has the same nouns like mother, like house, like wolf, but each noun from here has a different behaviors in each bounded context. So for the red hood, the mother was the initiator. She sent the red hood to the grandma. The house in the red hood was crucial, especially from the location perspective, because it was at the end of the forest. You need to go through the whole forest in order to get to your grandma's house. And wolf was also stateful, yeah? He started with, first of all, he talked with people, yeah? Second of all, he was changing its state. So he started pretending that he is a red hood, then he ate the grandma, then he was pretending he is grandma, then he ate the red hood, then he was killed. So the state was changing. And comparing that with the other bounded context we have here, with the three little pigs, it's a different story. So mother was just a background part, like she sent pigs out of home. Then house, it was really important, yeah? It was built either from straw, either from wood, or from bricks. And wolf was huffing and puffing in order to destroy the houses, yeah? So we see the difference. Even these nouns here look similar, they have different behaviors connected with them. How to plan this, how to find these domains and solutions for the problems identified by domains. The most popular thing recently is event storming. And the golden rule of event storming is to not that rule. Not to talk about event storming is a different thing. So golden rule is to use verbs in past tense and not to use data structures. And comparing it with the real world, it's kind of funny from my perspective, because when I talk with friends, we are using verbs, we are not using data structures. Let me show you the example. If someone asks me, what did you do yesterday? I'm not answering with beer, vodka, wine. I'm answering with, I drank too much. Yeah? So this is kind of natural for human beings to use verbs. But suddenly, out of nowhere, when we are starting a new development, new project, new software development project, we are thinking how to fit it into the database. We start thinking into nouns. And event storming is a technique which helps dividing, which helps focusing on the verbs themselves. So there are three different levels of event storming, and at the end level we have more event things than these events, but it's not a talk about event storming. I will just show the example later on the example of the three little pigs, obviously. What are the problems with event storming? Especially recently in the pandemic restriction times, the problem was that event storming requires people to be fit into one room, to meet in person and to put all the events with these orange cards on the wall. And the problem with that was that people couldn't meet in person, So that was the big issue. So thanks to that, people reinvented, in my eyes, the older techniques to get requirements from the business, from domain experts. And one of the techniques is, for instance, that modeling Whirlpool, which is rather focused on having some scenarios. We need to describe the full story, consult it with our business expert, and then iterate, write model, write code for the model, change the scenario, and so on and so forth. So that was the iterative manner. But also focused on the story, on the behaviors. And in current times, we don't have so many restrictions, but still, traveling is limited in some places, especially when you have distributed team with different countries. You don't necessarily can meet each other. And what we are doing in my current project in company, we are using some kind of hybrid approach. We are rather focusing on the storytelling, but we are also using this event storming notation. And I've seen, for instance, Alberto Brandolini, the inventor of event storming. I've seen one of the first recording, he tried the so-called remote event storming. And he said, no, I cannot use this term event storming on the remote sessions. It's rather like online collaborative session on top of event storming notation. And I would say, yeah, he did it on purpose, obviously, to not to make his term getting inflated. Inflation is a proper word for terms, probably. He wanted to prevent his invention from the inflation, but we will see. Probably in 2 years or something, we will have people telling that event storming didn't work for us on conferences, and they will refer to remote event storming. What we are doing, we are having this, for instance, on the bottom right corner, this is some kind of user stories, not user stories, but these domain stories converted and written together with this event storming notation. We will see how it goes. For now, it looks promising, but the code is not yet on production, so let me switch rather to tactical domain-driven design now. So, for the tactical one, we have different building blocks. We are currently now in the tactical the domain-driven design. We are in the concrete banded context, and we want to model its rules according to some building blocks, which are like entity and aggregate. And entity contains a business identifier. It's not a database entity, obviously. The aggregate is the place where you put all the rules which have to be matched together and saved in one transaction. Then you have stateless business logic. Then you have value objects. Then you have events. And there are also other things like specification policies. So this is how you build domains in your code, right? But what I really like personally when implementing, I'm using a Memento design pattern. So we are having in my code bases, I usually have something called snapshot. So on the aggregate, on the entity, you don't want to have getters and setters. You want to expose just business methods, but still, getters and setters can help you to be exposed to the REST service, to do some mapping on a database. So I'm using this snapshot like an X-ray picture of the aggregate. So this is just a picture, just a copy immutable thing. You cannot do much with the aggregate using snapshot, but snapshot is just like a read part of the system, yeah? And all this can be then presented in the code. So I like write some contracts for myself just to follow some good patterns. So assuming that the previous one was a good pattern, so having entity, I'm immediately implementing some rules that I want each of my entities to be able to get snapshot from. Yeah. So snapshot is here a value object which can be used to get data, as I said, but in an immutable manner. So it has just getters. Aggregate then can be defined as a specific entity. And only aggregate is the thing which can be stored in the repository. So repository accepts also only this aggregate. Yeah, and this is pretty easy to follow, and it can. Now it's better. Yeah, probably. Yeah. So the aggregate can be the only thing stored and retrieved from the repository. So these are the patterns I follow. Then there can be also events, and events will be later on a pretty important factor. So we know that there is the strategic level, then there is the tactical level. At the tactical level, in the concrete banded context, we have an aggregate. So what should be the aggregate for the three little pigs? Let me start with reminding you the business operations. What are the concepts of the three little pigs? So we have a requirement that we should build house, either from straw, from wood, or from bricks. We have a requirement that wolf is blowing house down, and then pig should escape. Then, after 2 failures, wolf should resign, and pig should be able to learn from the mistakes. What we skip intentionally to make code simpler is the mother of pigs, is the climbing through the chimney and eating the pigs. So knowing that, what should be the aggregate of our bounded context? Should it be pig, which can be either lazy or pretty productive? Should it be wolf? Should it be perhaps house, which can be built from these 3 ingredients? And whatever you picked now, I will ask you to stop right here, because once again, we fall the trap, yeah? We started thinking in nouns, while we should start thinking in behaviors, right? As I was mentioning that. When it comes to domain-driven design, we should be more like drunk too much than wine, beer, vodka, okay? So this is proposal, how to describe the story in the big picture event storming notation, yeah? So the events are the most important parts which happened to the systems, which changed our system state. And then, based on these events, we can put to other sessions, like design level event storming, and spot what are the rules we need to follow. And when I did this exercise, I suddenly discovered that the first aggregate I was thinking of shouldn't be the aggregate. The aggregate should respond to these requirements, like, can we handle the hurricane? Or can we let another pig in? And it became obvious, based on this notation, that we should aggregate the rules on the house. Because we can handle the house. Pick is in the house, and that's the reason Wolf is blowing on the house. So the command is executed on the house. So we need to group these two rules into one aggregate because they should be matched together. So this is this design level event storming, which leads to the conclusion that the aggregate is the house. And knowing that, we can mix this domain-driven design approach with clean architecture. So this is here is the picture which links. This is the link to the article with full explanation. But the key is that the domain layer is in the center of our solution. So these are the capabilities. These are the physics of the business, all the universal rules. And then we build our application around this physics. Yeah, we follow the requirements which are matched in the domain. So these are the capabilities, and around capabilities we have application services. This triangular-like shape can be, here it's described as component, but I would say it's the bounded context, right? So it's within this triangle, this part of the system, Wolf means the same, house means the same, and mother of the pigs also as well. Then around the application and around domain layer, we have these adapters. There are two kinds of adapters. Primary or driving, which tells our app what to do, the input adapters, let's say this way. And then there are output adapters, which are driven by the system, which are also called secondary. So for instance, domain can expose a port called like repository. And then we decide at the adapters level that this repository should be implemented through ORM, mapping, and to SQL database, right? What I'm missing here is one important adapter presented in every business application, right? Also, it looks similar, yeah? We have this rounding shape and then ball inside, so it's totally the same, definitely, the crucial adapter. But how to put all these adapters into the code? I've shown how to put tactical DDD, for instance. And here is the approach, which is kind of interesting and can broaden your horizons, I think. Because usually, when we think about splitting application into some layers, let's say we think about packages in Java. It's kind of natural. But there is also a module system, yeah? In Maven, Gradle, in Java itself now, we can use modules. So my proposal here, just for broadening the horizons, is to have each layer of the system in a separate module. And packages is the different way of dividing the application, different level. So let's see it in action. So domain can be splitted like that. It has a corresponding package called model at the end. Then there is the application layer, which has the package called app, and adapters. And as you can see, adapters is the biggest part here, but it has corresponding packages. So there are adapters provided, there are ports provided by the model, and the implementations for them are provided in the adapters module, same package. For app, we have app package. There are some ports, obviously, and there are implementations in the corresponding package in the different module. So I really like package private access, but it can be used between different modules as well. And here we have additional things like this input adapters and output adapters, so we can also use them as well, no problem with that. And then there is the final super adapter, let's say monolith, and the relation between them would be like that then. So these three things in the center, my ticker is not working. So these three things in the center are the bounded contexts. For each part of the system, we should have adapters, domain, and app, yeah? So 3 picks domain, 3 picks apps, 3 picks adapters. Then Red Hood domain, Red Hood app, Red Hood adapters, and so on and so forth. And then monolith should know just about adapters part, yeah? Then we have this domain, which is the capabilities of our system, and app should know about domain because it uses the code. App is telling what is the flow, when we want to actually read the aggregate from the domain, when we want to perform each action on the adapter and then save. Yeah? So app knows about domain, and adapters know both about app and domain because they need to implement ports from these parts. This shared part, this is just this helper let's say, set of interfaces which I've shown previously. Each part can have different tech stack, let's say. On the JVM world, for instance, domain, it would be nice to be tested with Groovy because this is very explicit programming language allowing plenty of syntax sugar. So perfect for DSL. Then for app, it can be handy to have, for instance, Kotlin for its consistency. And for adapters, this is the place when we have plenty of things. It could be maybe worth splitting adapters into separate modules, but for now I squeezed everything there. So we know we have these layers. We know how to present them in the system. We know the domain rules are coming from the event sourcing. So how about the application itself? I've said it should handle the life cycle of the aggregates and so on, but also there is another thing like user story and what we have on Jira usually, and this is the part for the application. Yeah, when we codified our universal business rules, then in the app we can play with these rules and match what we need. So for instance, the universal story we should have is to listen to the whole story, fairy tale, but then we should also handle some other comments like building the house itself. Like we can imagine this system, this domain we have is used for documenting, for register all the houses. Then we can have different things like as a wolf, I want to blow the house down, right? Why not? The most important user stories from here, I would say, are the green ones, because the whole story can be told together with these two green user stories or commands handled in the proper order. Then this visiting neighborhood, this sharing knowledge is rather a consequence of the green stories, yeah? So it should be rather like that. So let me dive into the code first. And I will start with running the application in the servlet mode. And we will see how it goes. So the green user stories are exposed via HTTP. As you can see, I have create, read, and delete method defined. So for creating the house, I have a method called post HTTP method, and I can send just that the owner of the house is a very lazy pig. After sending this, hopefully my app is running now, I got 201 created, and I can check in the headers that it was created under the identifier of 1. So I can read it now. I have some nice hints here, but I don't need them now. What are the further operations and so on. What I'm getting, as I built for the very lazy pig, I got a house built out of straw, yeah? And the house is obviously not yet destroyed. So I can create, not for the very lazy, but let's see it action, what happens when I create for the lazy pig. And when sending this request, I will get house with ID 2, and I can easily read it as well. And it was built out of wood. Now, what happens if I destroy, so send delete HTTP method under the first house? I got 204 no content, and by reading the, I can read the second, why not? In the second house, I can see now there are 2 pigs. So the one from the first house which was destroyed escaped, and I can also read the first house. As you can see, it has no tenants, and it is marked as a destroyed one. So how it happened? Let's start with the domain first. As we agreed, the aggregate should be the house. So let's see what house offers. There is a public class called house, and it implements that aggregate. So it's not only helping me, but it's also like a marker interface for my purposes. I can see that aggregate root, so public methods available on the aggregate, are as follows. So I can let the pig in. I can run brainstorming inside the house, so pigs can share the knowledge. I can get the snapshot, obviously. And there is a package private method called handle carrying. Why is this package private? Because this should be available not through the house itself, but through the domain service, which is called Big Bad Wolf service. And here, when I need to explain domain-driven design, I'm trying to put it like that. So our code, our documentation, our business knowledge should use the same ubiquitous language. So our code should as much reflect the normal, ordinary domain expert's language as possible. And reading this, skipping some Java keywords and stuff, we have like blow down, try, handle hurricane, retry blowing, and so on. So it sounds kinda natural, and it should be like that. This should be like that. At the end of the day, if 2 trials have failed, we are publishing the event called Wolf resigned from attacking. So events are here. Some of them, actually there are 2 events. So one of them can be published through the aggregate. So on the aggregate, which is house in our case, as you remember, on the aggregate, we have this method called handle hurricane. And here it uses a specification in Java. So if it cannot be blown down, then we throw undestructible house exception. But if it was destroyed, we are creating an event called house abandoned. And we are putting all the tenants inside the event body. So this is just a technique, one of the techniques you can use for your aggregates to publish events. So I'm having the private field here. Then I'm putting this field through the snapshot. So events are passed. Okay, once again. I can't see. 1, 2, 1, 2. Yeah, now it should be better. So on the house snapshot, I'm passing these events, and then in the adapters, I'm publishing them. So that's how it works. Actually, I'm not publishing. I mean, the implementation of publishing happens on the adapters, but there is also app which plays a significant role. So as you remember, there are some commands to be executed, and these commands should be compared with user stories. So ideally, or maybe, yeah, we could consider having each command per each user story. So in general, we have 3 PIX commands. First is the build house. Then we have a set of commands which are used for updating the house. And these commands are just containing the information needed for blowing down the house, for enter the house, for sharing the knowledge. So what is the potential content? We've already seen that we can already see here that, for instance, the FreePix command always contains update command always contains the ID, identifier of the house. Yeah. Then, for instance, the blowdown contains make use just of this ID. Enter not only uses the ID, but it also uses PIX, and so on and so forth. So this is how commands are implemented, and then they are handled by a dedicated service from the application layer. So this is the application service, contrary to the domain service we had called Big Bad Wolf service. So here I'm having a specific method called tell the story, which runs all the events in the proper order, but I'm also having the method for handling all the commands defined previously. So there is this build house handling, which just goes to the domain, takes some class from domain. So this is the factory, so we can check it, how it works. The factory is called house factory, and its implementation lies in the domain layer. So this is when we are passing a PIC there, we are choosing the policy based on the PIC behavior. How PIC ended in the system, that's maybe also interesting, because we've seen house is the aggregate, the wolf is the service, and here it's PIC, it's like simple enumeration. So the value object didn't need anything more specific. So the only behavior of the PIC is that it can learn from the mistakes. So for the very lazy PIC, it can become not lazy anymore. For lazy, it can also become not lazy anymore. So this is how it works. Then we have, coming back to this command handler, we are calling here from the application layer some domain objects in the proper order. Like here, for the update command, we always want to find, for the update command, we always want to find the corresponding aggregate. At the end of the day, we want to save this aggregate if it differs, and so on and so forth. And the handling of the specific commands later is either using aggregate itself, like here, or is using the domain service. Even here, we are using the aggregate, but I've decorated it with some syntax sugar from Kotlin. For events which are published, there is also a dedicated handler called event handler, obviously, and it uses command handler shown previously, but also something called query repository. The application layer is the place where we divide between commands and queries, if we want, obviously. And here I wanted, so I created a dedicated adapter, port, which is implemented in adapters, and this is the query repository. So this is a dedicated, more specific repository. Unlike domain repository, which contained just find, by, and save methods, here I'm having just read methods, and also methods helping me handling my user stories. So find the closest house, find house, but for the reading operation. So there is a dedicated read model here, which has also this flag of destroyed computed from the state of pigs. So this is basically how application got implemented. And event handler is also calling some methods, but from the application layer, because this is the application layer. It delegates to command handler, and command handler delegates to domain if needed. So the most important when it comes to actual working part is this adapters part. So here, as I mentioned, I'm having both application adapters and model adapters. So for model, it's simple, for instance, JDBC. And here, I introduced a little complicated, maybe I could simplify, but I wanted to divide. I didn't want any annotations from JDBC or JPA. Here are actually Spring JDBC, not pure Hibernate or something. So this annotation, like table, is not coming from JPA, Java Persistence. It's coming from Spring Framework data itself. So this is vanilla Spring JDBC mechanism, which is kind of interesting. And it was written with DDD in mind, as the documentation tells. So let's see it in action. So here we have this entity I created because I didn't want any annotations in the domain. Domain doesn't know anything about Spring, anything about Hibernate. So I'm creating from the house, which is aggregate, I'm creating a snapshot, and from the snapshot I'm creating the entity, as you can see here. And it also has some annotations from Spring, and this transit annotation is marked on the events. And what is interesting, Spring offers the mechanism in this JDBC of publishing events. It uses this basic application event publisher under the hood, but it's for sample purposes it can help. So if the method is marked with the annotation called domain events, everything returned from here will be published after saving the thing in the repository. So this is interesting. Aggregate was having events. They are not stored in the database, but after the saving, they are just published. And we want to clear events after the publication, so they are not published more than once. In this case, yeah, this is a simple application, as I mentioned. We have these input adapters. So here is this REST, which we demoed. And it's obviously a REST controller from Spring. So we built commands here, basically from the URL. So I had, for instance, this houses with identifier, so I know how to build the blow down command, right? For post, we had this houses information and the owner, so I was able to build the command for creating a new house. Yeah, so here it's built based from the body directly and passed to the application. Application passes to the domain, and so on and so forth. We have a different adapter as well here. So it is for running the application in the console mode. I will run it in a minute, and let me show the logs now, how they look. So as you can see, even after executing this a couple of REST requests, we got some logs in the console. How it happened? we don't have any logging utility in the application. We don't have any logging utility inside the domain, but we have it in adapters. I created aspect, which may be not the best idea, not always, but for logging, I think it can be done this way. So just this part, which is the output adapter, so this is the adapter driven by our application, is knowing what to log and when. So around the execution of our FreePix command handler, we are adding some logging. Around, for instance, or after having this blowdown operation performed by the domain service, so after this, we are logging some things. After returning from the nearest house, we are logging some things, and so on and so forth. So this how we can tell the whole story. But in order to do this, we need to open the application in the mode of console. So let me check the adapter to none. None. And run. So this will execute all the commands in a proper order in order to tell the whole story. So let's see how it goes. Where is the beginning? Once upon a time, there were 3 little pigs. JVM running. Everything as in fairy tale. Perfect. One night, the big bad wolf, who dearly loved to eat fat little piggies, came along and saw the first little pig in the house of straw, and so on and so forth, blah, blah, blah. Let's speed it up a bit, because, yeah, I can't wait the final solution. So the wolf followed them, and once he reached the house, began to shout, and so on and so forth. And the wolf huffed and puffed and huffed and puffed, and not was able to blow the house down. The 3 little pigs never had any trouble from him again. They learned from their mistakes, and they all lives happily ever after. Hikari pull shutdown initiated. So that's basically how you can play with domain-driven design, how you can learn it, I think. And we are not the only ones who are playing with 3 little pigs. So here is a screen from the Disney version. And as you can see in the corner, there is a picture. But for us, it's a totally different bounded context, right? Pig in that part of the system means totally different. We are looking at different properties of it, different behaviors than in the foreground. Yeah, so this is how it works. Here's the link to the code itself. Here's the link to the slides once again, and that's all I prepared for you. So thank you for your attention, and I can't wait to see the questions. Yeah, how to do so. Okay. You have extra time for asking the questions, and we are in 11. How do you handle the high threshold of new developers who are not used to this design? Well, depends on how heavy your company is hiring new people, right? But you always need an onboarding for a new joiner, yeah? It's not like every part of the system is also following this pattern. Usually, I would say, the easiest way, the most convenient way for developers to start is the adapters way, adapters place, yeah? Because here you have ordinary controllers which people are used to work with. Here you have ordinary SQL, for instance. So it may be the best to have some priorities on tickets and start introducing new people to the adapters part of the system and so on. But yeah, it's always onboarding which is required. In the domain, there was the exception throw at code later. You know, this is the example of the 3 little pigs. So everything here is opinionated. It's not maybe the perfect thing, but you are referring to the indestructible house exception, and I made it that way to handle the exception properly in the service. So we could have like a return method. We could skip the big bad wolf service and have everything on the aggregate itself. But yeah, I wouldn't. Here I also have this events on the aggregate. Yeah, it can be said it's also not a best pattern. Maybe we should return it from the command. But I don't think it's harming us. I think it's here in that case it's actually more readable. In other systems I'm having, I'm usually following the hierarchy of exceptions. Like the domain exceptions are all started with the business exception or something called similar, and then there are dedicated like business exception is extended by this indestructible by house exception and then by indestructible house exception. And at the end of the day, in adapters, I'm having the general handler for all the business exceptions, and I'm returning 400 errors for these exceptions. So here I consume the error and I publish the event as the result. But this is ordinary event handling, I would say, not the anti-pattern, that particular thing. But yeah, we can refactor that. The code is open source, so feel free. Shouldn't be value objects immutable. Pig is not. Actually, it is. This not lazy anymore is returning you the new pig, yeah, and the handling of the. So this is what you want to return when you learn from the mistake. So it returns the. Learned pig, yeah, but the previous object is not modified. So you have to handle modification at the aggregate, and it is handled here. Maybe not the perfect way, but brainstorming. So where is this? Yeah, run brainstorming. So I'm going through the pigs which are currently in place. I'm getting the pig and replacing this tnuts object with the new value. Yeah, so the new value. This is the entity called pigs3, which has some rules like invariance, like there can be no more than 3 pigs. I could probably also simplify here this handling. This run brainstorming, it should maybe this pigs3 should implement the business methods more readable than set. But yeah, it's not an immutable, I would say. Yeah. It may be confusing, but it's not immutable for sure. Don't you work for finance? Well, I'm not working for finance, but yeah, probably for finance people are really active at conferences and so on, so I know the patterns as well, they present them a lot. How to use transactional without mixing framework and the domain code, depending when you want to use it. Yeah, but I guess the question touches the application layer, and then then we will, because in domain we don't need transactional for sure. Yeah, because the application is the place where you follow the flow of the life cycle of the aggregates of the domain objects. So in the application, then you would need this transactional annotation, but maybe here is the hint a bit for you. So similar can be said about event handling, yeah? But I worked around this because the event handler doesn't have any annotations. The adapters then are configured the way they add actual event handling to that class. So let me show it here. I'm having this event handler, and in the configuration, I put this annotation, event listener, and it delegates to that event handler. This is the vanilla Java class, and its behavior, additional behavior coming from Spring is added in the adapters. Yeah, and it's also interesting here that I put this async, but without that configuration being registered by Spring, this async has no power, yeah? So this is also only registered if you have the servlet application type and if you are not in the testing. And then this event listener is not only event listener, but async event listener. So I would say for the transactional, you could maybe handle the same way, yeah? If you need transactional methods. How do you approach persisting bigger aggregates in relational databases, multiple tables, or saving in one, and mapping complex fields to JSON. Yeah, depending always on aggregate, but this mapping to JSON is rather popular, I would say, in code bases. Yeah, it's also possible to divide in multiple tables, but then it's like these internal entities, let's say. Yeah, I try always to hide entities. When I personally create a new aggregate, I try to put its internal entities as the static classes, and they can have different mapping to other entities, but yeah, to other tables. But I try to start simple, so usually starting with JSON, then converting to multiple tables. But here the question assumes that we are using SQL database for aggregate. You can also have NoSQL, right? Okay, and the last question, how do you keep track of what handles your events, even if your app has millions of lines? Yeah, so here it was simple because I had the central event handling. So this is rather a question to event-driven architecture, how to do this, how many events and so on, yeah? So events here in the code base are really simple. I'm using the Spring in-memory implementations for publishing events and so on. So these are vanilla Java objects, POJOs, yeah? Immutable, actually. So here, I'm not having any tracking mechanism, but usually when you have events and you really want to have moving toward event-driven architecture, after receiving event, you should store it in the database in order to make republishing. Yeah, before publishing event, you store it in the database to have a chance to publish events if the first publication failed. I'm not having this in the system, yeah, so you should somehow store the events. Also, when the events are received, you can also have additional information. So each system has a unique identifier. Depending on what system you use, also to publish the events. Like when you use some Kinesis from AWS or so Kafka, you have these topics, you have this not topics also, but only but these shards and things like that. So you specify some additional information on the event itself, like this aggregate was the source of the event, it publicated it, yeah? Then you have tracking ID. So each event, if it is republished or one event in system triggers another one, you are having like cause ID. So this event was caused by another event, and so on and so forth. So you basically face all the problems of distributed tracking. Yeah, so the patterns are known here. But this application was very simple. It was using in-memory events publication from Spring. Yeah, so that was a different story. I didn't have these additional fields on the event itself. It should be there in such cases. Okay. We are out of questions. Thank you very much for your attention and see you later.